Thank you, Michelle. Do we have some rice growers in here at all? Anyone that grows rice, other than Mike? Okay, good. What I'm going to talk about a little bit is the experiences that I've had in moving technology that I was involved in both water management and greenhouse gas and so forth, from these pretty little plots that were easy to manage to scaling it up to farmer-sized fields and larger areas. And I know as producers, you probably sit and listen to us and you think, well, this is really great, but that's nice, they can do this, and how are we going to do this on 1,000 acres, 2,000 acres, or 3,000 acres? So when I retired, I re-employed myself, and now I'm involved with both NGO and private sector, and basically looking at how do you move these technologies to a larger arena, i.e. farmers' fields, in a way that will make that technology as successful as it has been in these smaller plots and so forth, where it's very easy to manage. So, the whole question is, where are we going with it? Is it just going to sit there? It's going to depend on a whole lot of what I would call brave farmers, there's other names, that are willing to let us get out there and try to do it, and willing to invest time and energy and money in some cases to make it work. Okay, a lot of this involves sustainability. It's an overused word. The way I look at it is this is a farmer style, and that's not from farmers.com either. I just kind of made this one up, and it's maintain profitability, and that's really got to work. If that doesn't work, it's not going to work. It's a very simple thing. You have to stay in business. But do that while maintaining or improving air, soil, and water quality. And I added quantity, because that's really what we're going to be talking about. You can do a lot of these other things by just managing the quantity of water that you have out there. Okay, who's in this game and who helps? From the farmer's side, I think you need to all be aware that there are programs and people out there that will help you move down this road to better water management. The NRCS are a great tool, and they're in all the states. They have an emphasis now on water management, and basically they've expanded a lot of the practices that involve rice and water management. So you need to really know about this and make it part of your program. They have the standard programs. They also have special programs, which are climate change. This last year they had a special program in EQIP where you could go in and get extra funding and cost sharing and so forth for some of the equipment that you need to do this work. The RCPP programs, those are partnerships. There's one going now, and I work with that one, and it's with Ducks Unlimited, the NRCS, and the Rice Federation, and that's helped focusing on rice and focusing on water and nutrient management. So there are sources that you can use that actually are involved in that. There also is interest in coming in with private companies. There's technical assistance through RiceTech. I work with RiceTech, and we encourage our consultants to work with farmers on water management, demonstrations and so forth, so they sort of get in the groove of knowing what this is about, learning it, making it easier and so forth. And also now on the private side, there's interest in actually rewarding farmers a bit for doing this, and that comes through contracts that companies might have. Two of them that are thinking about it and moving in that direction are Mars and NOR. So it's not that there's no one out there to help you, nor that there's nothing at the end of the line. There's possibilities where you might go with the water management. Okay, this is really busy, but I want to show you. If you walk into your NRCS office, this is sort of what you're going to get if you're thinking about water management and you want to use an intermediate water plan. So you need to look and think about soil moisture. You have to choose it if you're going to do intermediate level. 3 of these. You have to do these, which are sort of basic, but you want to look at these 3 of these possibilities. Soil moisture being determined by in-field moisture sensors with data recorders collecting data at specified intervals. Well, that very much implies you're going to have some sort of an indicator out there, either of how deep the water is or how wet the soil is. You've got to go somewhere with that to do that. Or water level sensors used to determine decreases in the level of water in rice paddies. And this requires manual downloading. You can do it remotely, which is really what I'm encouraging everybody to do. Get the telemetry and get that. So you can look with rice, you can look at your cell phone, and you can say, this is how much water is in that field. Do I leave the pump off, or do I turn the pump on? And that's essential, and that's very important. They also require, and this is a requirement in the contract, so this is something you really have to do and think seriously about doing. Manual flow measuring devices, permanent or portable. So you have to think about, okay, I'm going to have to measure how much water I put on either that field or that group of fields. And we're going to talk a little bit about that later, because a lot of farmers have flow meters that they never look at. They're probably not functioning. And suddenly you've entered into agreement where they're asking you to say, well, how much water did you really put on that field? So think about that. We'll get into this just a little bit down the road. How many fields do you have? How many wells do you have? And how many risers do you have? How are those located? How can you isolate fields? What's the environment that you're going to try to come in and change this water management practice? So that all of these, and right down here, wetting and drying is part of it. If you're in Arkansas this last year and you agreed to do that, you would get $23 an acre. There's a cap on that in case you get it, but when you think about that, that's a very good reward for doing that type of water management if you can do it right and show that you're doing it. That's the other issue. You've got to be able to show that you're doing it. So this is the sort of thing that you will encounter, and this is from the Arkansas NRCS group. Okay, how much water might you be using now? And I think it's important to think about, you have a goal and you want to get better than the goal. And these are some figures that I got from averaging across studies across the Mid-South on how much water was used for a crooked levee, 38 acre inches, straight levee, 36, straight levee with Murray polypipe, 30, and zero grade, 22. Right away people are asking me, why are these not better? Well, the reason that they're not better is because going from crooked levee to straight levee and putting polypipe on doesn't impact you turning your water on and off. If you want to, you can put in polypipe, turn the water on, and just let it run, and you're going to be right up here or higher. So there's two things going on here. There's a technology you buy and don't manage, and there's a technology you buy and do manage. And so it was interesting, and it was an eye-opener to me when I looked at all the studies I could find around the Mid-South, and I realized that, yeah, if you're doing that technology and using it, you're going to do very well. But if you buy the technology, go to the coffee shop and say, I just saved this much water, you're probably not going to save that much water. You have to manage it. And that's the hard part. Okay? And then you add AWD. Now there's a group of farmers that I'm working with, and we had quite a bit of zero grade this year. They all used 10 to 15 acre inches of water. And so there you go, you're going to that. And as average of about 12 acre inches savings, and that's 326,000 gallons per acre. And they did that over about 8,000 acres. So figure out how many gallons they saved. Right away, you go back to you thinking about your NRCS program, but also think about you didn't have to pump this water. That's water you didn't have to pump. So you're looking at probably anywhere from about $15 to $30, $35 an acre savings in pumping, depending on what kind of pumps you're using and how they're located. So that's something that's right that you can use right now. Okay? Any questions on that? Okay, I won't spend too much time on AWD. Michelle covered that. One thing a few things that you need to remember is that the field, the water subsides. You don't pull the plug and let the water out. You just let it subside. We have a rule of thumb, or at least I use when I'm talking to growers, hold the flood after that initial flood. You put the nitrogen on for at least 14 days. Have the field flooded to this normal level at 14 days. If you shut the pump off, you're usually in early spring, you can let it dry down. It's probably going to go up to about 20 days and then it will get dry. We have 5 years of data with N15, and which shows you lose no nitrogen if you do that. In California, they're working on a system using the same thing. That the first dry down can be a very strong dry down, very dry. If you are obsessed with putting on a split application, put it on then while the ground is dry after your first dry down, and then just continue either AWD or normal flood for the rest of the season. You'll knock about 50% of the greenhouse gas off, you take about 30% of your water out, and you can do that. Okay, here is one of the biggest problems, and not sure how we're going to get around this. The larger the farms get, you tend to go from here to here to here to here. And then down here you sort of have the local meth head. So how are you going to do this? And this is hard to do. Oftentimes I find myself guilty of talking to up here. And then we get out into the field and what's happening here, 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 and here. And you go from clarity on, okay, we're going to do this water management practice, and this is how we've set it up, to absolute confusion down here. And one of the things that you can do is there's two things that I think are key to this. One is communication. You know, everybody in the food chain understanding exactly what's going to happen, what's changed and what's not changed. And I know it's a very difficult thing because it takes time, but the other part of that puzzle is the technologies that you can add to help you, if you're here, to see what's going on in those fields and to understand what's going on, and you know when to intervene and not intervene. And so this is and this is not, I'm not picking on anyone, Mike, I'm not picking on you. This is this is something that has been 100% people I work with. You know, everybody. And it's you are changing something that's been put there by granddad, by dad, and everybody's done it this way, and you're shifting it. So if you're going to shift that, you better shift it with everybody knowing they got to be in lockstep. And it's mean, but it has to happen that way. You got to get around it. Okay? So out to the field we go. Is there anyone here, because I don't have a long history with rice, can tell me what that thing is? You might have seen that along the road somewhere. You know, this is the sort of thing you get into. Yeah, I'd like to do this. Well, we're going to put a pump control unit here and a flow meter over here? I don't know. Because I'm not even sure what that is, if it's an antique water pump or if it's used or not used. So that's the sort of thing you get when you come out of the lab and you head out into the field. Anyone in here know what that is? I'm not sure either. What you do find is a lot of this. A lot of pumps that water comes out of the ground, goes a couple feet, goes back down in the ground again. And that's very, very common. And if you go back to the other slide I had, you have to measure the amount of water you're using. That implies you've got to have a flow meter somewhere. So where are we going to put a flow meter in these things? Well, a little bit about that. This is flow meter 101. Well, firstly, what I'd like to say about flow meters, there's a lot of them out there. There's bunches of them, more than I ever imagined. You pay for what you get. If you go buy the cheapest thing that you can find from the cheapest shop you can find, I highly suggest you paint it a color you like, put it in the field, enjoy your field art. Because you're going to have field art and no numbers. So you've got to think about getting something that will last more than 5 minutes and actually will do what it's supposed to do. So this is a case that not always in every case is the cheapest, the best. You don't want to have to go in every year and buy a new one. You want it to stay. So basically one of the rules is that 5 times the diameter, 5 to 10 times the diameter where the well comes out to where the flow meter should be. You go back to the other ones and you can see nana, 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 nana. You couldn't do that if you wanted to. So it's good to look at what you have ahead of time, because clearly if you're going to put flow meters in these sorts of what, you're going to have to dig it, you're going to have to bring a backhoe in, and it's going to be very, very expensive. So then you have to start thinking about, do I do this on risers? Do I measure off of risers? Do I measure off of pumps? Do I treat land that I own different than land that I'm renting? And all of that needs to go back into how you originally look at the situation. Okay? Also, you need to discharge position above the flow meter. If you have 6 inches here and it's just wide open and the water runs out, you can easily see you can be running that pipe half full, and it's going to still tick over that you had that full and give you a reading that you used. Now you might come up with something, you know you managed the water correctly and it says you use 80 acre inches as opposed to the 10 or 15 you shooting for. This can be remedied by either putting the pipe up, you can put an elbow on the end, or you can create some backflow. A lot of people just use a poly pipe, string it out and create some back pressure to make sure that there's no air in here, so when the flow meter is turning, you're actually getting that amount of water. In other words, you don't want to cheat yourself, because you can do that real easily. Okay, I suggest to everyone, look at the flow meter, look at the totalizer. If you have a totalizer, and before the season starts, please write down the numbers if you're going to look for that season. I mean, I'm saying that please because I've had people go in, put them in, and come back with a number at the end of the season. I said, where did it start? Oh, it had to start. Where did it start? 0? Oh no? Well, where did it start? Well, that's good, because you can just say how many acres of inches of water did you want to use, back calculate, and make up a start number. Now let's try not to do that. So here's the types of gauges that you might see. Make sure you know that they're gallons, acre inches, acre feet, and the conversions that you need to know to change that back into something you can use, usually gallons if you know how large the field is. So when you buy one, don't just stick it out there and say, okay, I'll read it at the end of the season. Doesn't work. Okay, here's what we like to see. These are pretty close to what they should be. Now here is, the faces didn't come up. The happy faces are risers. Now this is a grower that asked about, okay, I want to start measuring. He's got a well that has, you can discharge here, 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 and these are all field risers. Okay, he wants to AWD this field, he's got soybeans in this field, he's got corn over here, and some more rice over here. How many flow meters is that going to take? And this is not uncommon. So if you're going to sign up for a program, and I encourage you to sign up for a program, give some thought to what you're going to do to these sorts of situations, which was probably 2 generations of a farmer using this system and just adding to it, adding to it, and adding to it. Because it might require, when you go back to the people that you're going to go to, if you're using NRCS or whoever you're using, to sit down and do some planning on how are you going to do this so you can manage the water the way you want to manage the water. Because this is not an uncommon situation you're going to get into. You basically have to choose a field out here, and you end up putting flow meters on all the risers. That's the only way you can get it. You can't isolate it, you can't do anything unless you replumb the field. Okay, another one common, even with a lot with the 0 grade, is gravity is the cheapest way to move water, and I won't dispute that in any way, shape, or form. But what happens if you're moving the water down through these fields, you have an AWD here, and it gets dry, and you have another one up there, well, you've got to pump the water through that whole thing to get it done. Now, measuring the amount of water is relatively easy, because if you have one entry point, you can aggregate fields. And aggregating field's pretty important initially. If you're going to go into the contracts, you can say, okay, on these 4 fields, we're putting this 1 well, we can measure how much water goes in there. And that's very acceptable. You can do that. But you get into these situations where you have to cascade the water across the whole field as opposed to the same as you would with the levee, and then that's a problem. We try to aggregate in these fields. That they put in some pipes so they can use the canal and feed them separately, and we can pretty well manage field by field what's going on. But you still have to aggregate the total amount of water, and this is a good situation to use the depth gauges in. In other words, you can tell where you are and what you've got to do. This is my worst nightmare. This is a farmer that's got 1, 2, 3, 4 wells on this one pipe system. He's got 1 well isolated over here into 2 fields, but he's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 risers and 5 wells on one pipeline. And he wants to manage and know how much water goes into each of these individual fields. How can you do it? You really either have to break up that pipeline, which is a problem because the reason the pipeline is the way it is, half of the pumps don't work 3/4 of the time. So if you got half of the pumps not working 3/4 of the time, you have to have 5 on one line just to back you up in case something breaks down. So those are situations that I've encountered. They're not uncommon out there. And what I would encourage anyone doing this, and I would encourage everyone to do it, it's planning, planning, planning. You haven't thought about how to manage those fields in the past and water-wise, go out, take a look at them, get a good feeling for field size, pump capacity, risers, and how that water moves along, and get a strategy moving forward. And the long term you can do that is the best. Use all the existing resources. Because if you don't do that, you end up spending a lot of your money, and where you can get assistance, get it, and move forward with it. And that's all it is. Nothing happens on its own. Any questions? Yes?
Assuming that we can do it the same way every time, assuming it always works so well for us, would it suffice for the programs to do the portable test on the flow and then accurately time throughout the season what was running when?
Yeah. That is a very acceptable way. Do flow meters. It's good to do them at the beginning and mid-season and then at the end of the season, because you're going to get a real change through the season. But that and pipe planner and so forth, you have to do that for that. It's good to utilize those data. But yes, in aggregating fields, flow, that's a very good way of doing it. You don't have to have that you know,
Save
that
a lot
there.
of money on flow meters.
Oh yeah. Because a real good flow meter with a totalizer is you're looking about $1,500 to $2,000. But that, once you get that, or you get the sensors in the field, you can actually do that. If I were a 0 grade farmer, I would look at 10 to 15 acre inches every year. There's no need to get more than that. You can do it for that. Actually, we were able to, on some places, to use less water with rice than we were using with soybeans or corn. So don't let that scare you, that rice needs water, because we can do it for less actually than soybeans or corn and get by with it and get a good yield.
For those of you who were here to get CEU credits, the sign up is in the back.
Yeah. Yes.
What is the, I guess, the definition you're using from muddy to dry as far as moisture level without letting dry?
Okay, you want water level?
Well, yes.
Usually
0 to -2.
Yeah, well, yeah, if I were looking at water level at the soil surface, below and above the soil surface, I say, depending on how fast you can pump up the field, this is important, that 1 to 2 inches below that soil surface, you better hit your pump. And you won't, as Michelle shows, you really don't lose yield. There's been a lot of growers in Mississippi doing this for years. There's a lot now in Arkansas starting to do it. And honestly, some of these guys that have been doing this for years, they'll walk away from a field that would scare me to death and not work about it.
Yeah, we had a field this year for growers that we work with, that you could literally walk out there in your penny loafers if you wanted to, that dry.
Yeah.
And still didn't affect the yield.
I would say that's no problem, and I would say, till you get to green rain or half-inch interduct, rice you can literally beat up until that point. And I'll also say that you have to be conscious of the varieties or hybrids that you're using. You've got to have disease resistance, and you want something that can handle that, and the hybrids will do that. But that first dry down, you can really get it dry. And if you are one who likes to have that split, you can save 30% of your fertilizer by putting it on there, because you're going to lose ammonia if you throw it into water. So, I wouldn't mind having to check for every bit of fertilizer that went up in the air that dropped into water. That would be okay. But you can get by without doing it. Again, to do that, you've got to make sure everyone in your operation knows where it's going and how it's going to get there. Because if you have somebody else calling the airplane and somebody else doing this and this and this, again, it could be that telemetry will be the answer to that. Okay?
Thank you. I think we've kept you a little longer than I said I would.
Sorry.
So, thank you for joining us.